Hi guys, this is Mrs. Allison. Today we are going to talk about adding and subtracting radicals or roots. We are going to just focus again on square roots. That's all we're doing this year. As you move forward, geometry, algebra 2 trig, you'll get to see some higher roots, cube roots, fourth roots, fifth roots, etc. But for now, just square roots. So adding and subtracting radicals. Okay, so you should be following along on the note sheet that was given to you. That way you have some reference and a place you can write your thoughts and the answers down. So here we go. All right, so adding and subtracting radicals. So far, all we've really done is simplifying and multiplying. And those are two good skills, but now we need to look at what it means to add and subtract the radicals. And in order to add and subtracting, wow, that should not say subtracting, but it does. So here we go. In order to, let's see if I can scribble that out. Add and subtract. Let's subtract radicals. I'm trying to draw over it. In order to add and subtract radicals, the radicands, but let's talk about what a radicand is because that's a fancy word. The radicand is the number under the radical. So like if I had the square root of 2, the radicand is 2. This is the 2 part. Okay, so if I had 3 square root of 2, the square root of 2, the 2 is the radicand. So in order to add and subtract radicals, the radicand, or the number underneath the radical, must be the same. Okay, so we are going to think of radicals very much like we think about like terms. And I know this looks weird to say that because it says think of radicals like terms, but that's what I mean. We are going to go back to the idea of like terms that we did at the beginning of the year, and we're going to look at how that affects our radicals. So, for example, if I were to add 2x and 3x, can I do it? Are they like terms? Well, maybe let's define what a like term is, just as a reminder to ourselves that a like term has what? Well, it has the same variable, but what else does it have? It has the same exponent too. So remember, if you see x squared and x, those aren't like terms. So if we have the same variable and the same exponent, then they are like terms, but otherwise they're not like terms. So let's go back. 2x plus 3x, are they like terms? Yes. And if I were to add those together, I have 2 of one thing, 3 of the same thing. How many of the things do I have? Well, I have 5 of those things, so I have 5x. Okay, well, let's look at another example of like terms. If I have 3x plus 4y plus 5x, what are my like terms? Well, right, my 3x is a like term with the 5x, and then the 4y doesn't have a like term, so I can only combine the 3x and the 5x together to get 8x, and then all I can say is 8x plus 4y. I can't add those two together. Okay, so thinking through that, let's look at another example. Remember 2x plus 3x was 5x. Well, here I have 2 root 5 plus 3 root 5. So are the root 5s like terms? Yes, they are considered like terms. So 2 of something plus 3 of something gives me what? It gives me 5 of that something. So in this case, I would have 5 root 5. Very similar to how up above I had 2x plus 3x and I got 5x. Notice I don't change my variable. It doesn't change. Okay, if you have 2 apples and you had 3 apples, you don't get 5 oranges. You get 5 apples. So 2 plus 3 of the same thing gives me 5 of that same thing. Okay, well, let's look at another example. In this next example, it says 3 root 2 plus 4 root 3 plus 5 root 2. Okay, so what are my like terms? Well, noticing that it's very similar to the problem up above, I would say that my 3 root 2 and my 5 root 2 are considered like terms because they both are root 2. And then that 4 root 3 is its own. It doesn't have a like term with it. So I can really only combine the 3 root 2 and the 5 root 2 to give me 8 root 2 plus, and I can't say anything about the 4 root 3 because there's no other like term, so I have 8 root 2 plus 4 root 3. Okay, pause the video at this point and it's your turn to try some. Hopefully you've had a chance to look through these problems and try a couple and just see. Now, if you're stuck on these, substitute variables in. If you feel more comfortable with variables, plug the variables in. So maybe instead of this first one saying 5 root 7 minus 6 root 7, it says 5x minus 6x. What would you do if you were to subtract those? Well, they are like terms, so when I go and subtract them, 5 minus 6 is negative 1. Root 7 is all that's left. How'd you do? Okay, well, if you need to, pause the video now and try the next 3 and just see what you come up with. Okay, notice this next one. 15 root 6 plus 2 root 6, they're like terms, so I can add them, so I get 17 root 6. And this next one, it might do you a good to put a star by this one. The reason I want you to put a star by this one is for whatever reason, this is one that people tend to get wrong. So I want to think about this in terms of variables. So if I had x plus 7x, how many x's do I have? Hopefully you said 8x. Now the reason that's important is because this radical right here does have a number in front. And the number in front happens to be a 1. We don't ever write the 1. Just similar to how we don't always write the 1 with the x. So this 1 root 10 plus 7 root 10 gives me 8 root 10. Okay? And then similarly on the last one, if I have 10 root 5 minus root 5, I have 9 root 5. This one is also a little tricky. This is not 10. The root 5s don't go away. Think about it this way. Again, think about it like this. If you had 10x minus x, it doesn't become 10. You have 10 apples, you take 1 apple away. How many apples do you have? Not 10. You have 9 apples. It's not, we got to keep in mind that leading coefficient of 1 in front of these things. Okay? So how'd you do? Great. Okay. But what if they aren't the same radicands? As we said before, we can't combine them. Or can we? Let's look at this one. So I have 4 root 2 plus root 8. Okay? Initially, looking at this, I cannot combine them. But the question you should ask yourself, and it wasn't true in this last example, or in the beginning examples at all, but the question you should ask yourself is, can the radical be simplified? So can the radical be simplified? That's what you should ask yourself. Okay? And if the answer is yes, you should try simplifying to see if maybe it creates like terms. So for this example, what I'm going to do is I'm going to take the square root of 8 here, and I know I can rewrite the square root of 8 as the square root of 4 times 2. I tend to like method 1, so that's the one I'm sticking with. Okay? And this is still 4 root 2 plus the square root of 4 times 2. Now simplifying this, I know the square root of 4, I could rewrite it this way using the product property of radicals, and then that would give me 2 root 2. So if I look with my original problem, which was 4 root 2, and I'm adding it to 2 root 2, can I combine those? Yeah, I can combine those. 4 plus 2 is 6, so my total is 6 root 2. So we want to try to see if we can simplify the radical to see if we create like terms. Okay, you try some. Hit pause and come back. Okay, hopefully you had a chance to try these problems and let's see how we do. Okay, so as we look at this 3 root 3 and root 12, not like terms. But can I simplify root 12? Maybe. Let's try it. Okay, I know that root 12 is the same thing as saying root 4 times 3. And I'm just going to use the product property of radicals that we used last week. So I get 2 root 3. So root 12 is equivalent to 2 root 3. Now, I'm going to write the rest of the problem. So I have 3 root 3 minus. So I have 3 root 3 minus 2 root 3. Notice when I simplified root 12, I kind of just ignored that negative until the end when I need to think about it again, when I'm done simplifying. And what is 3 root 3 minus 2 root 3? Right, it's 1 root 3. So you can either write 1 root 3, although I'll tell you Math Excel doesn't love that as much. But I can write just root 3 because isn't it the same thing? Yeah. Okay. Did you get a chance to try this really fun one? I like this one. I think it's good. But it is a little messy. So let's start. I can see here that root 7 can't simplify. 7 and 1 are the only factors of 7. But 28 and 63 both simplify. So let's look at what those look like. So let's start with the 2 root 28. I have 2, let's see, I want to undo that. I want to do it in a different color. I have 2 times, well, what perfect square goes into 28? Well, I know 4 does, so 4 times 7. So that gives me 2 root 4 root 7, which gives me 2. Now remember, we multiply the outside numbers. So this gives me 4 root 7 when I multiply it by the 2 that was outside to begin with. Remember, this 2 here in the front is, I'll go through and underline all of those in white. So this 2 here is this 2 here is this 2 here is this 2 here, and then it gets multiplied by the 2. Okay, well, let's look at the next one. 6 root 63. Well, what perfect square goes into 63? Well, I have a 6. That needs to stay. How about 9 and 7? So we get 6 root 9 root 7, which means we get 6 times 3 root 7, which means we get 18 root 7. And as we said before, the 5 root 7 couldn't simplify. So I'm going to come all the way down here to where the problem was. It was 5 root 7 minus what's equivalent to 2 root 28 plus what's equivalent to 6 root 63. And when I do the math, 5 minus 4 is 1, plus 18 is 19. So my final answer would be 19 root 7. How'd you do? Okay, one of the things that would be kind of interesting to try if you have your calculators is if you type in, and you will never do this because I don't want an approximation, meaning I don't want decimal answers, I want radical answers. It's called simplified radical form, remember? If you were to type in this in your calculator, 5 root 7 minus 2 root 28 plus 6 root 63, and hit enter, you would get a decimal approximation. Okay, so when I type that into my calculator, I get a decimal approximation of about 50.26927491. Okay, and if you type in 19 root 7 into your calculator, you should get the exact same decimal approximation. So they're equivalent, even though their decimals are ugly, they're still the same number. So feel free to go back and watch this video again if you need to, or to refresh just a little bit. And we'll see you in the next video.